You've probably thought to yourself, what if everything around us, the people, the stars, our minds, bodies and souls, are just a realistic simulation? What if we're just merely characters out of some video game? Well, if you read science fiction books and watch movies, you've probably heard about this idea. The Matrix, for example, being the most popular one. Some physicists, philosophers say it could be possible. You technically could simulate everything else, so why couldn't you simulate a brain? We just don't have the technology for it yet. So, in March 1970, Martin Gardner opened a letter, jammed with ideas for his mathematical games called him, sent in by John Conway, then a mathematician at University of Cambridge. On page 9 there was an interesting heading, The Game of Life. It was an elegant mathematical model of computation, a cellular automation, a little machine of sorts with groups of cells that evolved from one iteration to another. And the game was pretty simple. Place any configuration on a grid and watch how it keeps evolving, changing, surviving from 3 simple rules that follow. Rule number 1, the birth rule. A dead cell with 3 live neighbors becomes alive. Rule number 2, death rule. A live cell with 0 or 1 neighbors dies of isolation, but a live cell with 4 or more neighbors dies of overcrowding. Rule number 3, survival rule. A live cell with 2 or 3 neighbors remains alive, and with each iteration, some cells live and some cells die, but life forms evolve from one generation to the next. I was interested if I could recreate the game of life by John Conway using these 3 simple rules inside Unity. And if I could create systems that were interesting enough for me to capture how long they were actually alive, and can I make a self-sustaining system myself? So I got to work. Firstly, I loaded my cell and I filled up the entire screen with it. Now I knew that every space in my current grid works, and I set the borders of the grid to be 1024 times 768. It's pretty small, but I think I'm gonna make it adjustable. When I randomized the number of cells shown on screen, it already started to look like the game of life, but there was a lot more work to be done. It was time to implement the rules. I had to check the number of neighbors. If I knew the number of neighbors, I could easily implement every rule, because every rule is based on the number of neighbors the cell has. So, count the north, east, south and west and all of the corner positions and add them to a variable called num_neighbors. And when I run the game, you can see that actually nothing changed. Everything is still static, but it gave me the number of neighbors each individual cell has. It doesn't matter if it's alive or dead. Now I can implement what happens based on the neighbor count. And now the real fun begins. We're going to give life to our game here. So I set up 2 if statements, one for if the cell is alive, the other if the cell is dead. So the first one is checking if the number of neighbors is different than 2 or 3. If it is, kill the cell. And the other one is checking if the number of neighbors is exactly 3. If it is, then the cell lives. But now when I start the game, it moves way too fast. Well, a simple timer will work. See, now it's great. The reason why it was so fast is because Unity natively runs the game at 60 frames per second. If we slow that down, we get something like this. This is great. We can see the simulation play out, and we can see how certain simulations last longer than others. But we're missing one key feature here: player input. We want to create our own system, testing them out and figuring out the longest lasting system. So, to make that, we needed a grid. And that was pretty simple to implement since this is a 2D layout, and there's a lot of scripts online on making grids on 2D layouts. I don't know anything about GL or on-post rendering, and I'm a programmer after all, so I just copied and pasted some code, but I made sure I understand at least some of it. This saves time and it implements how it should. Now we just adjust the grid size, colors, steps and so on. Only thing left is to implement the user input. So let's do that. Simple user input script would work like this. So when the first click is pressed, you check if you're in bound of the screen and make the cell on a specific point alive. Simple, huh? Now it'd be good if we could somehow pause the simulation until I finish building it and make it not always run. So I need a pause and a build function. Now the P key will pause the simulation and the B key will launch it. And we'll make a boolean and in update check if that boolean is true. And also I made it so when you press R, the game restarts. And now if I press play and remove the visible grid, I can actually make my own systems. And when I press B, the simulation starts and the game of life is finally in motion. And that is it. Pretty simple, right? And that's why this simple game took the world by storm. But how can a simple game be the evidence of life as simulation? Well, let me show you. I've got a couple of pretty popular systems or patterns already discovered by some other people. But after showing you that, I'll be trying some myself. Let's start. First, I tried a very popular pattern called the Arpentomino. This pattern will take 1103 generations to become stable. Even in our little simulation, where the size of the grid is smaller, it held up pretty well. You can see how this little pattern has this longevity for so many generations. It is crazy. So then I tried some static simulation. This one is called the Canoe and it never moves. And this one is called the Cloverleaf and it works like the oscillator. Then I tried one that was a bit more complicated, but it was definitely more interesting. This one is called the Hammerhead and it's a spaceship and it actually moves forward forever. It's a system designed to move like a spaceship on the grid, traveling far away. I played some static patterns and then I tried to shoot them with this glider gun, creating one hell of a simulation. But now it was my turn, it was turn for my designs. The first one I tested was a straight line. I liked it, and it was the first thing that I ever made in the game of life. It died pretty quickly though. Take a look at this weird one. I wanted to see how long would a system survive only based on the corner neighbors. Not long, I'm afraid. Then it was time for a huge plus sign, which obviously lasted a very short amount of time. And then I figured out that my problem is overpopulation. I only made these patterns which have interconnected neighbors and they have way too many neighbors. I couldn't for the life of me get a pattern that would work no more, no less than 2 minutes. Until I made the changes directly in the simulation. And let me explain. I set up this simulation and after it died I revived it of some sort. And this was by far the longest lasting simulation. And I obviously had to subscribe to my channel, and obviously for more school stuff like this. And this one actually lasts a decent amount of time, longer than others anyways. And this was definitely a fun challenge to make, this game of life, and it's really cool to see what comes out of it. And that is it for today's video. I hope you enjoyed it, and if you did, please subscribe, it will mean the world to me. And watch my other videos. Also, comment on what you would like to see next. Join my Discord for a nice chat, and I'll see you in the next one. Bye.